Welcome to the Deep Dive. Today we're plunging into a truly fascinating intersection. Imagine tackling some of the most complex problems in quantum computing, not with massive supercomputers, but like from your very own laptop.
And imagine a world where the power to do that is bought and sold on a decentralized global network.
Yeah, exactly. It sounds almost like science fiction, doesn't it? But it's becoming very real.
It really is. We're dissecting a recent due diligence report today. It unpacks a venture involving a company called Quantum Rings, and it's spearheaded by a pretty seasoned financial executive, a guy named Tom Finke.
Ah, okay.
And they're making this audacious move into the decentralized world of Bittensor with something called Subnet 63. They're branding it Bittensor.
Bittensor. Okay, interesting. So our mission in this deep dive is really to unpack these claimed technological breakthroughs.
Yeah.
We also need to evaluate the leadership, who's steering this ship, and explore this vision of creating a decentralized marketplace for quantum computation. We'll try to pull out the most important nuggets of knowledge and maybe some surprising facts for you.
Sounds good. So let's start maybe by just quickly revisiting why quantum simulation is such a formidable challenge for classical machines. As you know, the power of quantum computing, it fundamentally rests on principles like superposition.
Right, where a qubit isn't just 0 or 1, it can be both, sort of, at the same time.
Exactly. It exists in multiple states simultaneously. And that gives us this exponential edge over classical bits.
And that power, it just explodes even further with entanglement, right? Where qubits link up.
Yeah, they become interlinked, and their states instantly influence each other no matter how far apart they are. It's kind of spooky action at a distance, as Einstein put it.
Yeah. And these properties, they let quantum computers explore these just vast computational spaces, things classical computers couldn't even dream of touching.
Which sounds incredibly powerful, obviously. But it also sounds like it makes simulating them classically even harder, right? Is that where the exponential memory problem really bites?
Precisely. That's the core issue. To simulate, say, an n-qubit system classically, you're looking at storing 2 to the power of n complex numbers.
Okay, yeah.
It's an exponential memory problem. It grows incredibly fast.
Okay.
It becomes intractable.
So the direct method, state vector simulation, it's exact, but it hits a wall pretty quickly.
Yeah, you're talking maybe 35 qubits on your laptop, maybe 40, 45 on the world's biggest supercomputers. That's kind of the limit.
Which means developers are basically stuck playing with toy problems if they only use that exact method.
Pretty much.
So to push beyond that, they often turn to things like tensor networks. These are approximation techniques, right? They compress the information.
That's the idea. They let you simulate larger systems, maybe 50, maybe even 100 plus qubits sometimes.
But there's always a trade-off, isn't there?
Always. With tensor networks, the fidelity, the accuracy, it can really degrade, especially as the circuit gets more complex or the entanglement gets deeper.
Right. So you gain scale, maybe,
Yeah.
but you lose accuracy.
That's the crucial balancing act. And this brings us directly to quantum rings and their bold proposition.
Okay, so this is where quantum rings steps in. And they make this pretty audacious claim, but they're saying they have an advanced quantum simulator capable of, and get this, executing hundreds of qubits on your laptop.
Hundreds on a laptop. Wow.
Yeah, with millions of gate operations and, crucially, incredibly high fidelity.
So they're positioning themselves as better than state vector for scale, obviously, but also better than most tensor networks because of that fidelity issue.
Exactly. They're hitting both pain points.
And the name quantum rings, you mentioned, it hints at their method.
Yeah, it strongly suggests their underlying tech is likely tensor ring decomposition.
Okay.
It's a sophisticated kind of tensor network. It's known to be quite good at handling complex entanglement more efficiently than some simpler methods. Companies like Fujitsu have highlighted similar approaches. It's a known, powerful technique in the field.
Right, so it's not magic. It's advanced math and algorithms.
Probably highly optimized, yeah. But, and this is an important caveat, their SDK, the software development kit, it's closed source.
The black box problem.
Exactly. The precise algorithm is proprietary. So we can't just look under the hood. We have to rely on their public performance evidence.
Which is a challenge for trust, right? For users, investors.
Yeah.
How do they evaluate it?
It is a challenge. But the evidence they have provided, especially their big benchmark study against Google's Sycamore processor, that's actually remarkably compelling.
Okay, yeah, I remember reading about that. Their study, Effective Simulation of Sycamore Circuits.
That's the one. It's probably the most substantial piece of public validation they have.
So let's set the scene. Google's 2019 quantum supremacy experiment. They used their 53-qubit Sycamore chip for this task, random circuit sampling, RCS.
And Google claimed, famously, that their chip did it in 200 seconds, while the better classical supercomputer at the time would take, like, 10,000 years. A huge claim.
Huge claim. And they used a metric, linear cross-entropy benchmarking, XEB, right, to measure how close the results were to the ideal simulation. It's a score from 0 to 1.
Correct. So quantum rings took those same circuits from Google's experiment and simulated them. And here's the kicker. They did it on standard classical hardware. We're talking just 32 gigabytes of memory.
Okay, so accessible hardware. What were the results?
Pretty remarkable. They reported an average XEB score of 0.678 across all the circuits Google ran.
0.678 average. That's high.
It is. And even for the largest, most complex circuit, 53 qubits, 20 cycles deep, they got a score of 0.622.
Wow. Okay, those are strong numbers. But what's the real strategic significance here beyond just we can simulate it?
Well, two things. First, yeah, achieving these scores on accessible hardware is huge in itself. It democratizes things. Right. But the second point is maybe even more profound strategically. These scores, 0.678, 0.622, they actually exceed the fidelity Google reported for the physical Sycamore quantum processor itself.
Wait, they simulated it better than the real thing performed? How?
Because the real thing, the physical quantum computer, is noisy. Qubits decohere, gates have errors. The simulation, assuming quantum rings method is sound, represents the ideal quantum evolution, noise-free.
Ah, okay, so the simulation is cleaner than reality.
Exactly. And that's the strategic masterstroke. It positions quantum rings not just as a simulator, but potentially as a better development tool than today's noisy intermediate-scale quantum NISQ hardware.
So developers could use this to test and debug their algorithms with high fidelity before even trying to run them on expensive, noisy physical qubits.
Precisely. Rapid iteration, de-risking, could become the go-to environment for quantum algorithm development. That's the potential power here.
Okay, that is a very compelling angle. And beyond just the tech benchmarks, what about their ecosystem integration? Are they playing nice with others?
They seem to be. That adds a lot of credibility, too. They've got academic partnerships, University of Chicago, Arizona State University.
ASU, right? I saw their SDK is deployed on ASU's Sol supercomputer, and there was a strong endorsement from Dr. Gil Spire there.
Yeah, exactly. And industry ties, too. They've shown compatibility with the IBM Quantum Cloud platform in webinars. That's significant.
And they're doing community outreach.
Very savvy outreach, actually. They're sponsoring the IAQ-ACK 2025 Quantum Factorization Challenge at MIT.
Oh, interesting.
Yeah, and they're providing their SDK as the core simulation tool for the challenge. Plus, they're offering free one-year licenses for up to 200 qubits to participants.
That's smart. Get it into the hands of the next generation of quantum developers early. Build mindshare.
Totally. It's a classic adoption strategy.
Yeah.
And they're also members of key industry groups. Chicago Quantum Exchange, QEDC, Quantum Economic Development Consortium, Duality Quantum Accelerator.
So they're showing up in all the right places, being recognized by the established quantum community.
It definitely seems that way. It suggests they're seen as serious players, not just some, fringe project making wild claims.
Okay. So let's try to land on a provisional verdict for the technology itself. It sounds like it appears both plausible and legitimate.
I think so. It's likely based on a highly optimized proprietary engine using something like tensor ring decomposition. That's a known, powerful technique.
And the detailed Sycamore benchmark, the academic links, the community stuff, it all helps bolster that legitimacy.
Agreed. The primary remaining question mark, really, is that closed-source nature of the core algorithm.
The black box.
Yeah. I mean, there is a white paper on our Axorv, the preprint server,
right.
But it hasn't gone through rigorous peer review for a top-tier journal yet. That would be another level of validation.
Right, okay. So tech seems plausible, impressive even, with that one caveat. Now, who's actually driving this? Let's talk about the leadership. Tom Finke.
Right, Tom Finke. And the first thing you notice is he's not a quantum physicist. Not at all.
Yeah, his background is finance, right. High-level finance.
Extremely high level. Chairman and CEO of Barings LLC. He grew their assets under management massively, from $271 billion to over $350 billion.
Wow. Okay. Serious player.
Definitely. He was also chairman and CEO of a Dara Acquisition Corps. That's Sexback Experience.
Yeah.
Director at Invesco. His education, UVA undergrad, Duke MBA. It all points to deep expertise in capital markets, corporate strategy.
So his involvement tells us something crucial, doesn't it? It signals this isn't just a cool tech project.
Exactly. It signals a serious commercial and financial strategy. They're aiming for market adoption, revenue, maybe even a big exit eventually. This is structured like a serious business venture.
It's not just science for science's sake. It's about commercialization, probably targeting those high-value sectors like finance where he has connections.
That seems very likely. It's a crucial distinction.
And we need to clarify the different company names involved here because it can get a bit confusing. There's quantum rings, and then there's applied quantum software.
Right. Good point. Let's untangle that. Applied Quantum Software, or AQS, that seems to be Tom Finke's main company. It's a Delaware C Corp.
Okay.
And its focus is stated as quantum software and services specifically for the finance industry. So AQS looks like the primary commercial vehicle.
Got it. And quantum rings.
Quantum Rings is the developer of the actual simulator SDK we've been talking about. They're based in Colorado. Their CEO is Bob Wold. CTO is Venkat Kasirajan, who, interestingly, has authored a quantum computing textbook.
So quantum rings is the tech engine, the product team.
Precisely. So you have this symbiotic relationship. Quantum Rings builds the tech. AQS drives the commercialization, especially into finance, leveraging Finke's background.
Okay, that makes sense. And we should probably briefly mention there are other companies with similar names out there, right? Like Applied Quantum Consultancy or something about ballistics, just to avoid confusion.
Yeah, good call. Those seem unrelated. We're focused on applied quantum software, Finke's, and Quantum Rings, the SDK developer.
Got it. So this structure, it looks like that classic startup model, the business and tech founder pairing.
It really does, and it's often very effective. You have Quantum Rings Wold, Kasirajan as the technical heart. They're the ones engaging with scientists, developers, showing up at IKEA.
And then you have Applied Quantum Software with Finke as the commercial and strategic spearhead. He's the one talking to Wall Street VCs, enterprise clients, running those quantum for quants webinars.
Exactly. Let's each side focus on what they do best. And Finke's direct involvement, his track record, it really signals a very ambitious commercial path.
So assessing the leadership legitimacy, it seems strong, partly because it's not just one person trying to do everything.
I agree. Finke brings the financial credibility, the market access, the strategic vision needed to attract serious investment and big customers.
And his lack of deep technical quantum knowledge isn't really a weakness because that's covered by the dedicated technical team at Quantum Rings.
Right. It's actually a well-rounded structure. You have the tech expertise, and you have the business and financial acumen. Together, it forms a strategically sound leadership team.
Yeah. I saw some mention of a broken LinkedIn link somewhere in the due diligence, but that seems pretty irrelevant given the mountain of public evidence about Finke's career.
Yeah, totally negligible detail in the grand scheme of things.
Yeah.
His track record is very public and very strong.
Okay, so leadership looks solid. Now, let's get to what feels like maybe the most frontier aspect of this whole thing, the Bittensor connection. Subnet 63, Bittensor.
Yeah, this is where it gets really interesting, moving into the Web3 space. So for listeners who might not be super familiar with Bittensor, it's basically a decentralized protocol and allows people to create these specialized, incentive-driven marketplaces called subnets.
Right. You can think of it almost like an incentivized internet for digital commodities, not just data, like providing AI model outputs, or in this case, maybe computation.
Exactly. And within a subnet, you typically have two key roles. You have miners.
Miners provide the service, right? They run an AI model, or maybe in this case, the quantum simulation, and they get rewarded for doing good work.
Correct. And then you have validators. Their job is to evaluate the miner's work, check the quality, and assign scores.
And Bittensor has its own special consensus mechanism, UMA consensus, that takes all those scores and figures out how to distribute rewards.
Yeah, it aggregates the scores on-chain and distributes rewards in Bittensor's native token, TAO symbol.
Right. And there's another token involved too, right? The alpha token.
That's right. Each subnet also has its own unique alpha token. Owning this token represents sort of ownership or stake in that specific subnet. And crucially, the subnet owners, the people who create and run the subnet, they receive a significant chunk, 18% of the TAO emissions directed to their subnet.
So there's a strong financial incentive for people to create useful, innovative subnets.
A very strong incentive. It drives the whole ecosystem's growth.
Okay, so with that Bittensor background, let's connect the dots to Subnet 63, Bittensor.
The name itself is a pretty big clue, right? Bit for qBit, tensor for, well, the math underlying quantum states and AI.
Yeah, it's pretty direct.
And the creator listed is Tom Finke.
the finance guy whose company AQS endorses quantum rings.
And the only related quantum technology we know they're involved with is the quantum ring simulator.
So putting it all together, the conclusion seems almost inescapable, doesn't it?
It really does. Subnet 63, Bittensor, must be aiming to create the world's first decentralized, incentivized marketplace specifically for quantum circuit simulation.
Wow. Okay, that's a big deal. It's expanding Bittensor beyond just AI into like fundamental scientific computing.
It's a huge conceptual leap for the platform.
So how would this actually work? What are the proposed mechanics and what's the big challenge here?
Well, we have to infer a bit, but the likely setup is miners would install the Quantum Rings SDK, run a Bittensor node software.
Okay.
They'd receive quantum circuit tasks from the network, run the simulations using the Quantum Rings engine, and then send back the results.
All right, that sounds feasible, given the quantum rings tech seems capable. What about the validators?
Validators would source or generate the quantum circuits to be simulated. They'd distribute these tasks to the miners, collect the results, and here's the absolutely critical part. They have to evaluate the quality of those results.
Ah, and this sounds like where the major hurdle lies, the validation problem.
Bingo. This is the single greatest technical challenge, I think. For circuits that are actually hard, the ones you want to run on this network because they're classically intractable, how can a validator possibly trust that a miner's result is genuine, high fidelity, and not just random noise or, worse, completely fabricated?
Right, because if the validator could easily compute the correct answer themselves just to check,
Then there'd be no need for the miners in the first place. You just run it on the validator machine.
it's a bit of a paradox. How do you verify work that's supposed to be too hard to do easily?
It's a fundamental challenge in decentralized compute, especially for complex scientific tasks. The success and, frankly, the legitimacy of Bittensor really hinges on them having a robust solution for this.
So what are the potential strategies? Have they detailed any?
Not in detail publicly, as far as the report indicates, but we can speculate on possibilities, maybe probabilistic spot checking.
Like occasionally sending miners a circuit where the answer is known, just to keep them honest?
Exactly. Or maybe redundancy and consensus in the same hard problem to multiple miners and see if their results agree within some tolerance.
Okay, that makes sense.
Or perhaps benchmark-based trust scores. Miners might have to periodically prove their simulator's fidelity on standardized tests, like those Sycamore circuits, to maintain a good reputation score.
Longer term, maybe some advanced cryptography, zero-knowledge proofs or something.
That's definitely a long-term research goal in the broader field, but likely not feasible for this kind of complex simulation today. For now, it'll likely be a combination of those other methods.
But nailing that validation mechanism, that's the secret sauce. That's what will determine if Bittensor is truly trustworthy and viable.
Absolutely. It's the make-or-break technical piece for the subnet itself.
Okay, so putting it together, feasibility and legitimacy of this quantum subnet idea.
On feasibility, the miner's role seems proven, assuming the Quantum Rings SDK works as advertised. The huge question mark is that validation mechanism we just discussed.
Right. And economically, what's the appeal?
Well, it could create a liquid, on-demand market for a very high-value computational service quantum simulation. This could massively lower the barrier to entry for researchers, startups, smaller companies who can't afford supercomputer time or access to physical quantum hardware.
So democratizing access again, but through a market mechanism.
Exactly. And the legitimacy. It's largely bootstrapped by the credibility of Tom Finke and those technical benchmarks from Quantum Rings. People are willing to bet on it because of the players and the tech involved.
It really feels like a pioneering move, not just slapping another AI model onto Bittensor, but a real conceptual expansion into decentralized science, or DESI.
Totally agree. The narrative is incredibly powerful. Building a global, distributed supercomputer for quantum research, accessible to anyone.
Okay, let's try to synthesize all these different threads now. We've got the tech, the leadership, the Bittensor play. What's the grand narrative here?
The grand narrative, I think, is about creating decentralized quantum compute power, ready for the AI era and beyond. It's a multi-layered strategic initiative, and the story is actually quite coherent when you put it all together.
Okay, let's break down those layers. Layer one.
Layer one is the core technological breakthrough, or claimed breakthrough, Quantum Rings Simulator, making large-scale, high-fidelity quantum simulation accessible on commodity hardware.
Right, breaking free from dependence on supercomputers or those noisy physical quantum devices for development. And that's backed up, at least preliminarily, by that Sycamore white paper.
Yep. Then layer two is the commercial strategy.
This is where Tom Finke comes in. led by seasoned financial expertise, targeting high-value, near-term applications, probably finance first, given his background.
Makes sense. And finally, layer 3.
The visionary application. Bittensor on Bittensor, creating the first open, incentivized global marketplace for this quantum computation power.
Truly democratizing access using Web3 principles and incentive mechanisms.
That multi-layered narrative, it's clever. It appeals to different groups simultaneously, doesn't it? Developers get powerful tools, investors see a commercial strategy, the crypto community sees decentralization and innovation.
Exactly. It hits multiple audiences.
Okay, let's try putting this through a quick SWOT analysis. Strengths, weaknesses, opportunities, threats. What are the main strengths? Strengths. Potentially disruptive proprietary tech with those strong benchmark claims, strong bifurcated leadership, the tech team plus Finke. First mover advantage as a quantum subnet on Bittensor, and that powerful multi-layered narrative we just discussed.
Makes sense. Weaknesses.
Weaknesses. Definitely the closed source nature of the core tech, the black box risk.
Yeah.
The currently unproven or at least publicly undetailed validation mechanism for Subnet 63. That's a big one.
Yeah.
Also, reliance on the broader Bittensor network's health and security, which has faced challenges in the past, and maybe minor, but potential for brand confusion with other applied quantum names.
Okay. What about opportunities?
Huge opportunities. There's massive latent demand for accessible quantum simulation power, perfect positioning at the intersection of AI and quantum, two massive trends, and the potential to become really core infrastructure within the growing Bittensor ecosystem itself.
Right. If Bittensor succeeds, being an early, unique subnet could be very valuable. And threats. Threats are significant too. Intense competition. Google, NVIDIA, Fujitsu, Intel, Amazon, Microsoft, they all have quantum simulation platforms and initiatives.
Big players.
Very big. There's the long-term threat of technological obsolescence. If or when fault-tolerant quantum computers arrive, they might make simulation less critical for some tasks. And of course, the inherent volatility and regulatory uncertainty of the whole crypto market that Bittensor operates in.
Okay, that's a good overview. So if they want to succeed, constructing the right narrative for different audiences is key. How would you frame it?
Well, for investors, you'd focus on the picks and shovels aspect. They're investing in foundational quantum infrastructure. Potentially de-risked by Finke's commercial acumen. Talk about the huge total addressable market, TM, for quantum simulation, especially in finance, pharma, material science, and maybe highlight dual revenue streams. Direct SDK licensing plus participation in the subnet's economy via TAO and the alpha token.
Okay, picks and shovels, TAM, dual revenue. Got it. What about for technologists and developers?
For them, it's all about empowerment and accessibility. Breaking free from tool limitations. Running meaningful quantum circuits on their own laptop, not just toy problems, getting high-fidelity results quickly, and then the novel economic incentive. They can actually earn rewards by contributing their compute resources via Bittensor. That's new.
Yeah, turning your laptop into a potential revenue source for quantum research, that's cool. And for the crypto community.
For them, you lean into decentralization and democratization, expanding Bittensor's vision beyond AI into decentralized science, DeSci. You highlight the innovation of the first quantum subnet, and of course, the potential for the subnet's alpha token, the Bittensor token, presumably, to accrue value as the network grows.
Right, hitting those core Web3 values.
Exactly.
So let's pull it all together for a final assessment. Overall legitimacy.
Based on the report and public info, I'd say this venture appears highly legitimate. It's backed by credible people, like Finke. There's a tangible product, the Quantum Rings SDK, with impressive, albeit company-published benchmarks. They have strategic partnerships, academic links, and they're building on a well-established Web3 platform, Bittensor.
But the main risks remain.
Yes, the main risks are pretty standard for ambitious deep tech ventures. The proprietary nature of the core tech, meaning we rely on their claims. And that significant, possibly unsolved engineering hurdle of the validation problem for the Bittensor subnet. That's the big technical unknown.
Okay. So if someone listening is considering, getting involved or investing further, what are the key follow-up questions for due diligence?
Good question. I'd say, 1, try to get a deeper technical briefing on the simulator itself. Understand the methodology better, especially how it handles high levels of entanglement efficiently. That's often the tricky part for tensor networks.
Okay, push on the tech details.
2, scrutinize that Subnet 63 validation mechanism. Ask pointed questions. How exactly will validators verify correct simulations without being able to run them easily themselves? What are the specific protocols, tolerances, penalties?
Nail down the validation. Crucial.
3, clarify the precise corporate and IP structure between applied quantum software and quantum rings. Who owns what? How does the money flow?
Understand the business plumbing?
4, assess the detailed go-to-market strategy and revenue models. How much will the SDK cost? What are the projected earnings from the subnet? Who are the target initial customers?
Get the business plan details.
And 5, monitor for independent verification and community adoption. Keep an eye out for peer-reviewed publications. See what comes out of that IQ8ECK 2025 challenge. Do participants find the tool useful and powerful? That real-world feedback will be telling.
Great checklist. Okay, so to wrap up this deep dive, we've really explored a fascinating multi-layered venture today. It starts with a claimed quantum simulation breakthrough, something you can potentially run on your laptop.
Then layered on top is a seasoned financial leader, Tom Finke, driving the commercialization, aiming it likely at high-value markets first.
And finally, the most ambitious layer, this vision of building a decentralized global marketplace for quantum compute using Bittensor's Subnet 63, Bittensor.
It's a project aiming squarely at democratizing access to one of the most powerful computing paradigms emerging today. It could genuinely reshape how quantum research and development gets done worldwide.
Absolutely, which leaves you, the listener, with a truly fascinating question to ponder. What kind of new discoveries, what kind of breakthroughs could suddenly emerge when serious quantum computational power is no longer confined to just a few supercomputers or specialized labs?
Yeah, what happens when it's accessible, incentivized, and distributed across a global decentralized network?
It's a pretty exciting thought to mull over.